channel. In today's session, I am explaining about 2 marks questions which are very important for the university and examination, which will commence in the month of December last week or January last week. So please go through that questions carefully, and wherever you feel important, you can take it as a screenshot. Now, very first question in semiconductor, that is definition of intrinsic and extrinsic semiconductor. Definition of intrinsic and extrinsic semiconductor. Okay, a pure semiconductor crystal. A pure semiconductor crystal is known as intrinsic or pure semiconductor. Example for the intrinsic semiconductor is pure silicon and pure germanium are the example for the intrinsic semiconductor. Okay. Now, to increase the conductivity of intrinsic semiconductor, we have to dope with the trivalent impurities. We have to dope with the trivalent impurities or pentavalent impurities. Okay. By doping into those material, the resultant material is called as extrinsic semiconductor. In simple definition point of view, how can we define intersection semiconductor? An impure semiconductor is known as extrinsic semiconductor. Okay. Now, depending on the type of impurity or dopant to be added into the intrinsic semiconductor, again we can classify these extrinsic into two categories. The first category is N-type semiconductor and the second category is P-type semiconductor. Okay, this is the first question, that is definition of intrinsic and extrinsic semiconductor. Then after this first question, then we'll discuss about the second question. And what is the second question? Definition of intrinsic, definition of N-type semiconductor and P-type semiconductor. Okay, now let us discuss about the N-type semiconductor. If small amount of pentavalent impurities. Who are pentavalent impurities? Phosphorus, arsenic, antimony and bismuth. These elements belongs to the pentavalent impurity atoms. So, in these pentavalent impurity atoms, if you observe the valency electron number in these atoms, you can observe 5 as valency. Therefore, these are called as pentavalent impurity atoms. Okay. Now, if you can dope with small amount of pentavalent impurity atoms into pure semiconductor or intrinsic semiconductor, then the resultant semiconductor is known as N-type semiconductor. So, after the getting N-type semiconductor, the resultant material contains majority number of free electrons and minority number of holes. This is about N-type semiconductor. Now, let us discuss about the P-type semiconductor. How can we prepare P-type semiconductor? So, now let us discuss about the P-type semiconductor. If a small amount of trivalent impurity atoms, who are trivalent impurity atoms? Boron, aluminum, gallium or indium. These elements are having 3 as valency. So, such elements are called as trivalent atoms. If you can add or if you can dope trivalent impurity atoms into the pure semiconductor or intrinsic semiconductor, then it gives resultant material whose name is called as P-type semiconductor. Now, in P-type semiconductor, there exist more number of holes, that is majority number of holes and minority number of free electrons. This is about N-type and P-type semiconductor. Now, coming to the other question, define doping or what is doping? The addition of impurity atoms into pure atoms, that addition process is called as doping. The atoms to be added into the respective material, those are called as dopants. Okay. In general scenario, the doping ratio is 1:10⁸. In general scenario, the doping ratio is 1:10⁸. So, in this ratio, 1 belongs to one belongs to impurity atom. One belongs to impurity atom, and 10 power 8, 10 power 8 belongs to pure atoms. This is a general ratio of doping. Then we will discuss about the another question, that is define Fermi level. Define Fermi level, and we have to identify the location of Fermi level in intrinsic semiconductor, N-type semiconductor and P-type semiconductor. Now these levels can be represented in the energy band diagram. Generally this question is important for the semester end examination. Okay, now first of all we will discuss about the Fermi energy level. So Fermi energy level is the highest energy level which separates completely occupied energy levels and completely unoccupied energy level. That level is called as a Fermi level. In the case of intrinsic semiconductor, Fermi level exists exactly middle of the valency band and conduction band. Now coming to the N-type semiconductor, Fermi level present in between the donor level and the conduction band. Whereas in the P-type semiconductor, Fermi level present between the acceptor level and the valency band. This is about position of Fermi level in intrinsic N-type semiconductor and P-type semiconductor. Now we can locate this semiconductor, this Fermi level position in the energy band diagram. Now this diagram is called as energy band diagram. In some examinations, if you observe the previous question papers related to the JNTUA Anantapur, or JNTUA Kakinada, or JNTUA Hyderabad, in some papers they are asking about location of, or identify the location of Fermi level in intrinsic N-type and P-type with the help of the band energy diagram. In such cases, simply you can draw this diagram, you will get 2 marks out of 2 marks. Now we will discuss about the intrinsic semiconductor. Now in intrinsic semiconductor, just we discussed about the intrinsic semiconductor. How can you define intrinsic semiconductor? A pure semiconductor is called as intrinsic semiconductor. In intrinsic semiconductor, this is called as valency band and it is known as a conduction band. Between the valency band and the conduction band, energy gap present. Usually it is denoted by Eg. Okay. Now in energy gap, Fermi level lies exactly middle of the valency band and conduction band. Now coming to the another type, that is N-type semiconductor. Coming to the N-type semiconductor, in the case of N-type semiconductor, we will discuss about first of all donor level. Okay, donor level is present in the N-type semiconductor. This donor level is due to the addition of pentavalent impurity atoms into the pure atoms, which creates extra electron. That extra electron creates new energy level, which is exactly below the bottom of the conduction band. Now in this diagram, this line represents donor energy level. Now it is a conduction band. Between the conduction band and donor level, Fermi level lies. This is about N-type semiconductor Fermi level position. Now coming to the P-type semiconductor. First we'll discuss what is P-type semiconductor. If small amount of trivalent impurity atoms are added into pure silicon or pure germanium, the resultant material is called as P-type semiconductor. Now because of addition of trivalent impurity atom in P-type semiconductor, new energy level is created above the top of the valency band. This energy level is called as acceptor level. Okay. Now between the acceptor level and the valency band, one Fermi level is identified. Now this is a position of Fermi level in p-type semiconductor. Coming to the conclusion, Fermi level present exactly middle of the valency band and conduction band in the case of intrinsic semiconductor. Coming to the p-type semiconductor, Fermi level present exactly middle of the conduction band and donor level. Now coming to the p-type semiconductor, Fermi level present between the acceptor level and valency band. If you can draw this diagram, definitely you will get 2 out of 2 marks without alternates. Okay. Now please observe this presentation carefully, and wherever you feel important, you can take as a screenshot and you prepare for the end examinations carefully. Okay. Short answers plays an important role in the examination for getting more marks. Okay. Now I'm focusing all the short answers and covering each and every topic. So be careful and observe the presentation and understand the presentation. If you are having any doubt, please comment me in the comment section. I will give clarification for your doubts. Okay. Now see the presentation completely till to the ending. In this chapter, in this presentation, I will cover all the 2 marks questions. In the upcoming session, after the completion of all 2 marks questions related to the all units, I will focus on the university question paper discussion. I will take one university question paper starting from 2023, starting from 2023 supplementary examination, 2023 supplementary examination. I will explain each and every question paper back to 5 years. So we follow my presentations completely and will get clear information and definitely will pass, will get good marks in the university examination. Now coming to the next question. What is the next question? Now you read the question, write the expression for the intrinsic carrier concentration of intrinsic semiconductor. Now in intrinsic semiconductor, now there exist equal number of free electrons and holes. This number can be represented by using a symbol Ni. Ni stands for intrinsic number of charge carriers. That means charge carrier means who carries the charge is called a charge carrier. Now this equation can be represented as Nc into Nv whole power 1 by 2 is into e power of minus Eg divided by k suffix b. Now I am writing once again, Ni is equal to Nc into Nv into e power minus Eg divided by 2 kBt. Now in this expression, E is nothing but energy gap present between the valence band and conduction band. Kb is the Boltzmann constant and T is the applied temperature. Okay. Now Nc and Nv are known as conduction band constant and valency band constant. These are nothing but pseudo constants, or simply we can call it as a constants only. Now in the similar way, dear students, see the presentation completely and you can take the screenshot and prepare for the second mid examination as well as the university examination. Short answer questions plays an important role for getting good marks in the university exams. Okay, now without skipping the video, listen carefully, and if you are having any doubt, comment in the comment section. Then another question is write expression for the conductivity of intrinsic semiconductor. So conductivity is represented by the symbol sigma I. I stands for intrinsic. Sigma I means conductivity of intrinsic semiconductor. Sigma I is equal to A e power minus Eg divided by 2 kBt, where A is a constant, that is equal to NcNv whole power 1 by 2 into E small e into mu n plus mu p. where in that equation, already we discussed just now, Eg is the energy gap, Kb is the Boltzmann constant, T is the temperature, and mu n and mu p. Mu n and mu p belongs to the mobility of the electron and mobility of the hole. This question also important. Then coming to the another question. Discuss the effect of temperature on the energy level. This question is very important. This question asked in the university exams frequent గా ఈ క్వశ్చన్ అడిగారు అనమాట. కాబట్టి ఇలాంటి క్వశ్చన్స్ whenever questions are important which are repeating in the university and examination, you care on these questions completely. Okay, now next question is discuss the effect of temperature on the Fermi level. Now in this question, so if temperature of n-type semiconductor is increased, then what happened? More number of electrons and more number of holes are created at a very high temperature. The concentration of electrons, here concentration means number, the concentration of electrons is more than the concentration of the donor electrons. Because of this reason, concentration of electrons and holes are equal. It results position of Fermi level shift towards the middle of the energy gap. In the previous case, Fermi level present exactly middle of the donor level and conduction band, but high temperature. At high temperature, Fermi level position changes towards the middle of the valency band and conduction band. Now, if the temperature of n-type and p-type semiconductor is increased gradually, then Fermi level shift or move towards the center of the forbidden energy band. If you are feeling this question is lengthy, the same question can be written in 2 lines. How can you write? If temperature of n-type and p-type semiconductor is increased, then what you can write in simple sentence? Fermi level moves towards the center of the energy gap or forbidden energy gap. You can write this question, this line also, you will get the 2 marks. Then coming to the another question, write the expression for the Fermi energy level in n-type and p-type semiconductor. Now in the case of n-type semiconductor, equation for the Fermi level can be represented by using this equation. EF is equal to EC minus KBT into log NC divided by NV, where EC is the conduction band energy, EF is the Fermi energy, Kb is the Boltzmann constant, and T is the absolute temperature, and finally Nc and Nv belongs to constant. This is about Fermi level equation in n-type semiconductor. The similar way we'll discuss about the p-type semiconductor. In the case of p-type semiconductor, Fermi level equation EF is equal to EV plus KBT into log NV divided by NA. Now you go through this equation and you will note as it is. Now another important question is define drift. This question also important. How can we define drift? When external electric field is applied to a semiconductor, then what happens? The charge carriers. Who are charge carriers? Electrons and holes are the charge carrier. These electrons and holes move in a particular direction. Because of applied electric field, electrons and holes moving in a particular direction, which causes conductivity. This phenomenon is known as drift of charge carrier. Because of drift of charge carrier, it will create drift current వస్తుంది. ఏమొస్తుంది? Drift current వస్తుంది. This question is very important for the essay question also, which we'll discuss in the upcoming session. Then another question is, when does drifting of charge carrier takes place in a semiconductor? When electric field is applied to semiconductor, then charge carriers move or drift from one side to the another side. So drift is possible only electric field is applied. That is a drift phenomena. Then in the similar way, we have to write equation for the conductivity of semiconductor due to the drift. Drift valna conductivity equation rayali. So how can we write equation? Sigma is equal to, sigma means conductivity of semiconductor because of which process? Drift process. Sigma is equal to En mu n plus Ep mu p. In this equation, n is equal to number of electrons and p is equal to number of holes. Then mu n and mu p related to the mobility of electron and mobility of hole. And similarly, we can discuss about the another question, that is when diffusion of charge carrier takes place inside of the semiconductor. This is another mechanism. This is another mechanism. In the previous question, what we discussed? We discussed about the drift. Drift is a mechanism which occurs inside of the semiconductor when electric field is applied. But whereas diffusion of charge carrier, diffusion is another mechanism. The diffusion takes place whenever unequal concentration is present. Unequal concentration of electrons and holes are present inside of the semiconductor, which increases the movement of electrons from high concentration region to low concentration region. This transport mechanism is called as diffusion. In simple way, movement of charge carriers from high level to low level. Electrons అనేటివి holes అనేటివి unequal number గా ఎక్కడెక్కడైతే ఉంటాయో అటువంటి కండిషన్స్ లో the excess electrons and excess holes move from the high level to low level. That phenomena of movement is called as diffusion. Because of diffusion of charge carriers, there what we will observe? Diffusion current వస్తుంది. Diffusion current వస్తుంది. ఇంతకుముందు ఏం చెప్పాను మీకు? డ్రిఫ్ట్ కరెంట్ ఒకటి చెప్పాను. డ్రిఫ్ట్ కరెంట్ ఎప్పుడు వస్తుంది? whenever electric field is applied to that p-type or n-type semiconductor, then drift current occurs. Now coming to the diffusion process, whenever unequal number of electrons and holes are present, then what happens? More number of charge carriers move towards the less number, high concentration to low concentration region. That movement is called as diffusion process. Diffusion process will give diffusion current. Now another question, very important, that is called as Einstein's relation. Another question is Einstein's relation. For essay question also, this question is very important. So how can define Einstein's relation? The relation between, this is the question number 13. The relation between diffusion coefficient and mobility of electrons and holes now is called as Einstein's relation. Now mathematically this equation can be represented as dN by dP is equal to mu n by mu p. In that expression, dN and dP is known as diffusion coefficient of electrons and holes. Similarly, mu n and mu p belongs to mobility of free electrons and holes. This is about the Einstein's relation. This question also important for the examination. Then the last question and one more questions are there. Then another question is what is Hall effect? This question is very important. Anta important ante anta important idi. If you can observe the university previous question papers, definitely without this question there is no question paper. Either it may be asked in the short answer or it may be asked in the essay question. So you focus on this question without fail. Okay. Now how can you define Hall effect? Now when a current carrying semiconductor is placed in a perpendicular magnetic field or transverse magnetic field, then what happens? New potential difference or new electric field is going to develop in a direction perpendicular to both electric field and magnetic field. Electric field and magnetic field. This phenomenon is known as Hall effect. Now in this phenomena, the produced voltage is called as a Hall voltage. It is denoted by VH. Once again I am telling to you, this is very important question. Dear students, go through these questions carefully and you can take screenshot and you can prepare as it is. Definitely will get the 2 marks out of 2 marks in the short answer section. Now coming to the another important question related to the Hall effect. Now what is the question? Applications of Hall effect. Now first application is Hall effect is used Hall effect is used to find the given semiconductor is N-type semiconductor or P-type semiconductor, are also used to find given semiconductor is intrinsic semiconductor. Then it is used to find Hall effect is used to find mobility of electrons and holes, and also used to find conductivity of the given semiconductor. It may be N-type or P-type. Then another application of the Hall effect is used to find the magnetic field strength. Magnetic field strength kanukovalana kuda you can use the Hall effect. Then another application of Hall effect is if by knowing the Hall coefficient, and mobility of charge carriers, what we can find number of electrons and holes kuda kanukovachu. So this is about applications of Hall effect. Then coming to the another question. Dear students, go through the presentation completely without skipping. If you are skipping, definitely you will lose short answer question. Out of these number of short answer question, which question will come to the examination, we don't know. If we will focus all the questions, definitely among these questions I am giving here, definitely 1 or 2 will come to the examination. Okay. Now the another question is direct band gap and indirect band gap semiconductor. It is also important for the exam. Okay. Now what is direct band gap semiconductor? In some semiconductors, there exist minimum of the conduction band which lies exactly above the maximum of the valency band. Wherever this occurs or wherever it observed, such type of semiconductor is called as direct band gap semiconductor. Because of this reason, what happened? Free electrons which are available at the bottom of the conduction band, they can combine minimum with the directly with the maximum of the valency band. Because of this process, recombination is going to take place. Because of this recombination, what happened? Photons are emitted in the form of radiation. Depending on the material which we are using, different colors are going to emit from that respective material. In generally, we are using which materials to make a direct band gap semiconductor? Gallium arsenide based junction diode, gallium arsenide phosphide based junction diodes. Also example for the LED. These are the example for the direct band gap semiconductor. Now coming to the another question, what is a indirect band gap semiconductor? In some semiconductor, there is no minimum. There is a difference between the direct and indirect. Direct lemutundi minimum conduction band untundi ikkada no minimum conduction band. So there is no minimum of the conduction band which lies above the top of the valency band in the energy band diagram. Such semiconductors are known as indirect band gap semiconductor. Due to this reason, what happened? The electrons and holes cannot recombine directly with the holes. This causes emission of energy in the form of temperature, not radiation, in the form of temperature. This is an example for the indirect silicon and germanium based diodes. Now coming to the last one question. What is the negative temperature coefficient of resistance? If temperature of a semiconductor is increased, then its resistance also is going to decrease. Then if resistance is going to decrease, conductance is going to increase. This property is called as negative temperature coefficient of resistance. Generally, this property is observed in the semiconductors only. The semiconductors only. Now, this is important for the short answer. What is the energy gap of silicon and germanium? In the case of silicon material, energy gap is 1.2 electron volt, and energy gap in the case of germanium is 0.7 electron volt. And last question is, what is law of mass action? The product of electron concentration and hole concentration is a constant in given semiconductor is called a law of mass action. You go through this equation carefully and you prepare all these questions. Definitely from these questions for the university examination, definitely one question or two questions will come to the university examination. In the upcoming session, I will discuss about the next previous unit, that is unit number 4 I will discuss. Unit number 4 means it is quantum mechanics and free electron theory of conductors. I will discuss 2 marks questions in this unit 4. Please go through this presentation and subscribe and share to your friends. Definitely it will be useful. Then that's all, my dear students. Please don't waste time. Please focus on the examination for getting good marks. Thank you for watching this presentation.